So we will now do the high pressure calibration using the DPI 620 Genie and the PV622, the pneumatic pressure station, which can do from vacuum to 100 bar. Let's do a 70 bar today. We will be using the DPI 104 as a device under test. You can take a look at the how to prepare for a pressure calibration video, and this also will be applicable to DPI 612 PFP instrument. Now, in quick, connect the right fitting, connect it to the device by hand tight only. We already selected the right instrument, which is the 100 bar instrument. Now I have a couple of pressure modules to select from, or actually it's more than two. I have this one, which is 0.2 bar. I have 2 bar. I have these two. I have these are 200 bar. This one is the normal one, or this is the PM620T, which is having an ultimate accuracy, which is 4 times better than the PM620, the normal one. So let's use this one today. We will fit it by hand tight. Good. As we said, no need, it will detect automatically. No need for any setup. We are ready to go now. So here is the pressure. Let's change the unit from millibar to bar. And now we are at 0, so we can start. Let me quickly brief you about the calibrator here. We have the stroke pump. This is where we can make pressure strokes to put pressure inside the mechanism. The stroke will give you around 0.4 to 0.5 bar per stroke. This is the release valve. This is the non-return valve or the refill valve. We will see how this works. And this is the volume adjuster. The volume adjuster is used to increase or decrease the volume of the internal chamber. Here I can, if I take it clockwise, I will be decreasing the volume. If I take it counterclockwise, I will decrease the volume inside. So because I'm doing a positive pressure now, let me keep it fully counterclockwise. And we can start now. We will close that one. We will keep this one open, or we can close it. It's fine, both are fine. And we can start the pressure operation. Let me turn this on. Okay. Start building the pressure. You can see the stroke is giving around 0.4 to 0.5 bar. As you can see, the pressure is increasing in gradual amount. This will help me to get any point in between. As you can see, despite of the hand connection, there is no leak. It's perfectly airtight. If I get smaller stroke, I will get lower pressure steps. Because we are going on high pressure, let's make it on full strokes. Let's take it here, it's easier now. Okay. Now it starts becoming hard because the pressure is building inside and I'm trying to push the air. See, it's very easy. I always recommend my customers and my team to use this side of the hand to put the pressure. This will make it easier. Let's take a break now and see. 18.1, 18.05. We are not sure, we need just to match the digits to be sure that we are doing right. So I'll increase it by 1 digit now. I increase the resolution. So I have a difference of like 0.04 bar. Comparing that to the full scale of this is nothing, but this is an error at the end, which we need to document. As you can see, it became hard now. Let's stop here and see what can we do. Now I will use this one. This is a volume adjuster. This will decrease the internal volume by minimum the half. So at least I will decrease the internal volume by half. So the pressure should double. Now we started with 20 point something. As you can see, this one is easy. It's not like this one, because I'm not fighting with the pressure now. The screw is doing that in my behalf. See, 32. So from 20, we almost doubled the pressure. Now 40 bar, we doubled the pressure now by using this easy to use volume adjuster, which is the wheel. 50 bar, 53, 54, 56, 57, 60. So we make it triple. See, I achieved the 70 bar very easily. Now, because I put a lot of pressure inside in a very short time, as you can see, the readings are still a bit fluctuating because of the temperature effect. So the energy I put from my body to the instruments, it transferred inside, it causes a heat. Now it's cooling down gradually, but it's not, as you can see, the rate is not that high. If you increase it, let's increase it by 1 digit and see. Okay, resolution. See, it's stable on 3 digits. It will take some time to, but it's going up and down, means that it's not a leak, it's a temperature effect. Let's go back to our resolution to match the device and the test resolution and wait for quite some time. In the meanwhile, if I take this back now, the pressure will drop. Let's take it to the maximum and see where can we reach. So as you can see, we started by 20 bar, we reached around 90, it's 88. So we increased it by more than 4 times. So if I put 25, for example, in the first place, I would achieve 100 very easily. This is the way to operate this instrument. Now, I wanted to make the pressure down to 85, for example. See, I have a good resolution and fine adjustment. Let's take it to 85 point something. Wait for the cooling down, then do the calibration. Now the error is around 85 to so we have 0.07 bar. Is it acceptable or not? This depends on the application you are using the device under test for, and this what you can determine when you do your calibration certificate. Or either you can use the internal analysis function to determine the pass or fail, or you can use the Foresight software to tell if it is pass or fail, and you can refer to the video of Foresight if you wanted to see how this is done. Now, the non-return valve is a valve which will help me to hold the pressure which I have created. So if I close this one now, the bottom one, as you can see, if I take the wheel back, now the pressure is hold, it's not decreasing. So I can take it fully back. As you can see, there is no pressure fluctuation. It's holding the pressure for me. Even if I open the vent completely, it is still holding the pressure. So I'm now taking this fully. The pressure is still holding at 85, means that I am having a pressure hold inside the instrument. Let me return this now and try something with you. I'll now use this. See, it's fully free. So I can start from zero and build more pressure. If I open the bottom valve, I will return the chamber to the zero. As you can see, the pressure releasing is so safe, it's gradual, and I can do the proper control on the calibration.